So let's discuss another problem where we have to find the inverse of 101 mod uh, 4620. Now, in finding the inverse of this, will be taking the help of two concepts. One is the Euclidean algorithm, and second is the Bézout's theorem or coefficients. Now, when we have this expression with modulus, at first what we'll try to find is that the GCD of 101 and 4620 is 1. We'll use the Euclidean algorithm. Then second, once we are able to find it, then we'll do the backtracking to find the equation which is similar to S times A plus T times B. So in that case, this is the A and this is the B. So we should get an equation which is of the form of S times 101 plus T times 4620. Now, then the value of S will give us the inverse. So let's begin with the Euclidean algorithm. So since we have 4620 and we have 101, therefore if 4620 is the dividend, then it is equal to 45 times 101, and we'll get a remainder of 75. Then this will be the dividend, 101, and this will be the divisor. So you'll get 1 times 75, and if you divide it by 75, if you divide 101 by 75, you'll get a quotient of 1 and a remainder of 26. Then following the same trend, which is this becomes the dividend, 75, and this becomes the divisor. So we'll have 2 times 26 plus 23. So again, making this as the dividend and this as the divisor. So we'll have 1 times 23 and we'll get a remainder of 3. Then again, this will be 23 and this as the divisor. So this is 7 times 3 plus 2. So we'll get a quotient of 7 and a remainder of 2. Repeating it again, three is equal to 1 times 2 plus 1. So this is we'll repeat it here. So 2 is 2 times 1. So this is where we'll stop, plus 0. So what we found as GCD is 1. Now we will work our ways backwards again till we'll have an expression which is of the form of S times 101 plus T times 4620, because this will give us the inverse. So using this equation, we'll get 1 is equal to 3 minus 1 times 2. Let me zoom it a bit. One is equal to 3 minus 1 times 2. And we'll get the value of, since in this equation we still don't have 101 and we don't have 4620. So what we'll do is we'll again backtrack and we'll find the value of 2 from this equation. So 1 will be equal to 3 minus 1 times. So this equation gives us the value of 2, which is 23 minus 7 times 3. Then if you rewrite this, this will be equal to 3 minus 1 times 23. Minus and minus will be plus. This will be plus 7 times 3. So this will be equal to minus 1 times 23 plus this 3, and 7 times 3 will add up. So this will be 8 times 3. So what we have here is 8, and this equation again moving upwards. So we are actually moving backwards here. This equation will give us the value of 3. So this will be equal to minus 1 times 23 plus 8 times the value of 3 using this equation will be equal to 26 minus 1 times 23. Now if we simplify this further, this is minus 1 times 23 plus 8 times 26 minus 8 times 23. So this will be equal to 8 times 26 minus 9 times 23. And this equation will give us the value of 23. So this will be equal to 8 times 26 minus 9 times 75 minus 2 times 26. So what we'll get is 8 times 26 minus 9 times 75. Minus and minus will be plus. This will be 18 times 26. So this can then be further written as 26 times 26 minus 9 times 75. And this equation will give us a value of 26. So what we'll get is 26 times 101 minus 1 times 75 minus 9 times 75. So this is equal to 26 times 101 minus 26 times 75 minus 9 times 75. So this will become 20. This will become equal to, since we have to put the terms with 75 separately, so this will be 26 times 101 minus 26 and 9, that's equal to 35. 35 times 75. Still, we have not obtained the term that contains both 101 and 4620. Now we will get the value of 75 using this equation, the starting point. So we'll get the value of 75 as 4620 minus 45 times 101. So that will be equal to 26 times 101 minus 35 times 4620 minus 45 times 101. So this will be equal to 26 times 101 minus 35 times 4620. This will be plus 35 times 45 times 101. Then this will be further, if you simplify this, what we'll get is, if we combine the terms with 101, if we combine this with this, what we'll get in the end is 1601 times 101 minus 35 times 4620. So this is actually of the form of S times A plus T times B, or in other words, this is of the form of S times 101, S times 101 plus T times 4620. So in this case, what we'll get is the value of S is 1601 and the value of T is minus 35. So S is equal to, the value of S is equal to 1601 and the value of T is 4620. So we know that S gives us the inverse. Therefore, this is the inverse of 101 mod 4620. So that's how we obtained the inverse using Euclidean algorithm and Bézout's theorem.